When we look at numbers, what is the first thing that we do? We compare them. Here, 6 is greater than 3 and 4 is smaller than 9. Similarly, 3 squared is greater than 2 squared since we know that 3 is greater than 2. Here the exponents are the same and the number that has a greater base is greater. And this is always true provided that the bases are positive. So when we have two numbers written in the exponential form, we need not evaluate them every time we want to compare them. Now if these numbers are surds, the methods wouldn't change. For instance, if we have root 3 and root 2, we know that root 3 is greater than root 2 because 3 is greater than 2. We were able to compare these two surds because they had the same order. The order here is 2. So when we are comparing two surds of the same order, the surd with the greater radicand is greater. Let's get back to comparing numbers which are written in the exponential form. Let's say we have 2 squared and 2 cubed. Obviously, 2 cubed is greater. If the bases are equal and the exponents are different, the number with the greater exponent is greater. So when we have two surds and the same radicand, the surd with the greater exponent is greater, right? Let's say we have root 2 and cube root 2. Root 2 is 2 to the power half and cube root 2 is 2 to the power 1/3. Since half is greater than 1/3, root 2 is greater than cube root 2. Now, root 2 has an order of 2 and cube root 2 has an order of 3. Here, it is the surd with the lower order, that is root 2, which is greater. So when the radicand is the same, the surd with the lower order is greater. Let's look back at comparing numbers which have the same base. Now, we have half squared and half cubed. Which is greater? Half squared is greater than half cubed, right? But wait, the exponent on half squared is lesser than the exponent on half cubed. Seems like the number with the lesser exponent is greater. That's because the number is lesser than 1. The more we multiply a number lesser than 1, the lesser it gets. For instance, half is lesser than 1. Multiply it by half and we get 1/4, which is lesser than half. And so on. So when the base is lesser than 1, the number with the lesser exponent is greater. Now when we have surds with a radicand less than 1, the same rule holds true. Cube root of the half is greater than root half. So the surd with the lower order has a lower value when the radicand is less than 1. Now you know how we compare two surds when there's something common between the surds.